Dear students, welcome. Thank you for tuning to another video. We are continuing our discussion in the design development course, and we are talking about the final specifications. In this video, I'm going to be talking about the first step or tool in the method of setting final specification, which is technical model development. It's a very important step. It is all engineering. This is where our skills as engineers will come and will show. To clarify this concept of what is modeling, we've did something similar when we created a lot of concepts. Now we're going to go a little bit more into what is modeling in general. Modeling is a way for us as engineers to try to predict the value of a parameter by creating a virtual model that has a set of inputs, and our desired value or our desired target will be the output. To clarify this, models are analytical or physical approximation of concepts. At this point, you probably selected your concept, then you have your metrics. And you will say, well, if I want to have an approximation, how would that look like? And this is where our knowledge and skills in mathematics and physics will show up, because if you are trying to identify a metric, let's say strength, you need to know how do we measure a strength? What is the mathematical or physical formula that is used to measure strength? If you are talking about stiffness, so analytically, how are we calculating stiffness? So what are the inputs that do I need to put in that equations or formula to give me stiffness? And this is how we're going to break things in modeling, the technical models. It also can be used to check if the design variable affects or a target specification. There is a typo here. So it's variables affect. Can we use to check if a design variable affect a target specification? So here's what you need to put and keep in your mind. First, we are modeling, so we're doing approximations. We are trying to identify the value of one parameter, one physical parameter, let's say stiffness or strength. So what you need to do actually is something like this. First, we will go back to our example, the mountain bike, and this is a schematic of how a model will look like. So let's say I'm interested in identifying the final value of the lateral stiffness. Now, in order to calculate stiffness, I need the geometry, I need the material property that I'm using, and the geometry of the tube, the support, geometry of the tube and the support, and also the mounting points. How is the suspension system is set it up. So this is a model. So you need to be careful about how do you set up these models, because you can have a lot of different models. I would go with the easiest route, which is identifying a formula, a mathematical or physical formula that we know about to calculate stiffness, and I will put all the independent input on the left, and the output will be on the right. So for your projects, what you need to do, as a exercise, select a couple of your metrics. And that what is the formula, mathematical formula or physical formula, the law, how it would look like, and try to build this setup. Now, in modeling, we know what's going to be showing inside this box. It's the formula, it's the mathematics. Is that I'm going to be doing with the geometry and the material properties and the mounting points is going to be calculated inside that box. So I would hope that you will try this exercise and to select a couple of metrics and do this for your project. So keep in mind, design variables, they have to be independent, and you have the product specification metrics. Now, if you build this and you build the formula, use the formula, you will start changing, let's say, the material properties. Let's say if we are talking about its strength, let's say the elastic modulus, which is a material property. So let's say I will use this model and I will put the elastic modulus to be 10 gigapascal. And then I will repeat it again with 5 gigapascal and then 25 gigapascal. And I will see what's the output will look like. And this is what we do as engineers. This is actually basic engineering practices in product design development. So I would hope that you will be able to practice this. And if you try this a couple of times, you will see what is the value that the feasible value that you can get for your lateral stiffness. I hope that clarifies this. And I encourage you all to try it for a couple of your metrics, and let's see how this is going to work. I will be asking in the coming activity grid to do something similar, and I will give you more information. Thank you for watching, and till next time.